Alright. Hello class, this is part 2 of the calculus winter break assignment. Alright, now here we are looking for maximum once again. Now, we could take the derivative and then try to figure out, but in this case, one easy thing which you can realize is that sine, it always goes up to from -1 to 1. It fluctuates between these two values, but how can you have the absolute value of that to be equal to be the maximum? Then we will realize that that will be maximum if sine of x is -1. And we get to realize -1 minus 1/2 is equal to simply 3/2 because negative sign disappears. Alright. Now, how about this? This seems to be somewhat difficult, but if you look at it carefully, this may not be that bad here. So, if you have to rewrite this one, then it will be simply simple as this: a to the exponential form, a to the a over 4. See, must be equal to 2 to the a power. But when you write it in this way, since a is common, it is kind of difficult for you to look at. So let's cancel out a by raising to the 1 over a power. Then we will end up getting a to the 1/4 power is equal to 2. Now how can you get rid of 1/4 power? By raising to the 4th power. And a will be equal to simply 16. There it goes. How about this? F is an odd function, which the following must necessarily be true. So odd function basically means this, as you can see from here. What happened to f prime? F of -x was originally a negation of f of x. But when you take the derivative, then here we get f of -x times -1 because of the derivative of -x. That must be equal to simply negative of f prime of x. Negation cancels out, becomes positive. Now all of a sudden we have even function, right? F of the prime right here, or f of x. So our answer will be 4 choice. Now how about this one? Notice e to the nx. Every time you take the derivative, e to the nx will be same as e to the nx, but only portion that will be different is n to the x power. I mean, e to the n, the exponent nx, it will take its derivative and then simply leave n after each derivative. So we are doing this one n number of times. So that's basically what will happen, which is choice A. Alright, number 40. Here, all we have to do is simply find the derivative, but use the chain product rule here and chain rule. So let's try looking at them. So what we end up getting, secant square of x comma y. Right? That's the derivative of the outside. The derivative of the inside becomes here x times y prime plus y. That was the derivative of the left side. Derivative of the right side is equal to simply 1 because derivative of x is equal to 1. Now, then we realize x y prime plus y must be equal to 1 over secant square xy. In other words, this is simply cosine square of xy. Now, in order for us to have y prime by itself, all we have to do is simply subtract y and we get x y prime is equal to cosine square of xy times negative y, if you're interested in. Now, to have the y prime by itself, we have to divide by x. We get y prime is equal to negative cosine square xy, but the y has to be multiplied right here, all over x, which came from x times y prime. So that would have been our answer, which now we get E as our answer, therefore. Alright, the next question. The solution of this one was equal to negative 1 and 2. Now, in other words, when you plug in negative 1, that was equal to 0. Now, that means x over 2 must be equal to negative 1, and x over 2 must be equal to 2. And here we get x equals negative 1 half. Here we get x equal to negative 1 half, and then 4. I mean, here, I'm sorry, this is equal to negative 2, and then which will be choice E. Alright, here comes the last question. If f is continuous, now, key word here is the continuous. Since it's continuous, one thing that we get to realize is C, which would have been definition of the derivative, where the limit is equal to f of that particular value. Right? Now, alright, that's it. And here,